So far, we've created an account and project and loaded data into our cloud data warehouse. So now it's time to transform this data and get it business ready, all within the Data Productivity Cloud. Let's start by creating a transformation pipeline. Now we have a new empty transformation pipeline, which lets us use special transformation components to affect our data. The first thing we want to do is to pull our data into the pipeline. So we can start working on it. Let's add a new component. Click Read here on the categories so we can see our different read component options. If we read the description of our components, we can think, well, we've already got our tables and we need to read data from them. So we'll use a table input component. Open up the properties and add in the first of our tables under the target table. We've already got posts and user tables here because we ran our orchestration job and created these tables. So let's choose the first of those tables, posts. Another good way of checking what tables we have available to us is if we go to schemas on the left-hand side. You can check what tables exist in your schema. So if you're making new tables, you can check whether they already exist here. Let's finish configuring our table input component, where we're going to pull in every column name. Then let's repeat the process for our table of user data. We can also sample the data directly from the component before performing any transformations. So let's perform our first transformation to clean up our data a little bit. You may notice the user ID in the posts table has a decimal place, where the user ID in the users table doesn't. This is due to us pulling two different data sources that handle data differently to one another. So we're going to use the convert type component to change the float data type for this column in the posts table into a number. Add a convert type component to the canvas and open up its properties. Select the column and change it to its new data type. While we're here, let's change the likes column as well, because that should also be a number. Now, if we sample the data from the convert type component, you can see the effect the component has had on the data. So you can now see the user ID is a number, not a float. Now we're ready to connect this all together. To recap, we have two data sets. One has data on post titles, authors, and likes. The other set has user data with names and locations. We'd like to use a single data set so we can see the names of each post author and where they come from. And luckily, we can join the two data sets by using their user IDs to do exactly that. Let's add a new component, which will be the join component. This is doing a regular SQL join, which means we need multiple data sources to join together. So let's also drag a connection from the users table. Now both of these data sources are going into the join component. Let's choose our main table data source, and you'll notice under the data sources it's recognizing the components that are connected to the join rather than the tables. As you can see, the data source includes the convert type component and the users table, and not the posts table. This is because the join component is connected to the convert type component and means that we're joining to the transformed data, not the original untransformed data. For the main table, we'll select convert type as we want to join the transformed data, but we'll give it an alias of posts so it's easier to identify what this data is. Now let's click into joins, where we can join to the users table. We're going to keep the alias of users for this, and for the join type, we'll use an inner join, as we're happy to discard posts without valid author records. Next up, we're going to create our join expression. So down here, you can see all of the incoming columns and the different data sources they come from. So here we've got users and posts. We'll join the posts user ID with the users user ID. Click the plus button while hovering over the posts.userid column to add it to the expression. Or we can also type it in if we choose. Enter an equal symbol and then let's add the user ID from the user's source. In effect, we're joining our two tables on the knowledge that the user IDs are a column element with the same meaning in each dataset. Under column mappings, we choose what data we want this join to output. Let's click Add All Columns so we can see what we're working with. Here is a good opportunity to do a little bit of cleaning up. So let's say, for example, we don't need the row IDs, the post IDs, or the user IDs, as for our analysis, we only need the usernames. Let's use the columns that make our data clear and readable. Click Save, and now again let's sample the data. And taking a look, we can see we've got all of our original rows, one for every post. We can see the post title, who wrote it, the country it came from, and how many likes the post got. So our data is now much more useful than when we first loaded it. And yep, I'm happy with that, so let's write it out to a new table, as currently our transformations only exist transiently within this pipeline. Writing the data out to a new table will store it permanently in the data warehouse. Let's write our data into a new table in our data warehouse. Let's add one more component, as we don't have an existing table to write the data to, and we need to write our data to a new table. For this, we'll need a rewrite table component. Let's give our table a new name, and we don't want this to clash with our existing posts or users table. So let's call this social media output. We can see this has been validated, and so again, we are ready to run our transformation pipeline. Running the pipeline will go step by step through our components, transforming our data and writing it out. After running the pipeline, we can go to the schemas and we can check our table has been created. And look, there it is, our social media output table now exists. In the next video, we'll automate our pipelines, as well as looking at version control and data lineage.